Welcome to the On-Demand Training for Exploring Science 2019. We want to motivate students to be lifelong learners, those curious people that are always trying to find answers to questions about the world around them. With our National Geographic materials, we can do that by exposing them to explorers, the scientists and engineers that are out there in the field every day answering those kinds of questions. Exploring Science will bring science to students through the new Next Generation Science Standards Framework. Finally, our number one job as educators is to achieve mastery of content and prepare our students to be successful in college and in their career after college. Those behaviors that will make them successful have to start early. A rigorous science program in elementary school can teach students those 21st century skills that will make them academically successful. Let's look at the student components for a minute. Your kindergarten young explorers will have everything they need in big book format. You will receive 4 big books, one for life science, one for earth science, one for physical science, and one called Let's Do Science that introduces your students to what science really is. You will have all of these in print and digital format. In grades 1 through 5, a student book has all of the units of study. Each grade level is also available in a digital format as well as print. There is a comprehensive teacher's edition at each grade level. What's really great about the teacher's edition is that the student edition is integrated right into the pages. Our team of program consultants were chosen as experts in their field to ensure Exploring Science brings real-world science to your classroom. Doctors Bell, Trundle, Butler, and Mulbash are the science experts, while Dr. Liederman brings her experience with inquiry and investigative science. Doctors Duke and Cervetti are our literacy specialists to make sure the textual readings are engaging but academically appropriate for your students. With all these scientists and engineers bringing their explorations into your classrooms, children won't just be reading about science, they will actually see how science happens in the world around them. Exploring Science helps you teach phenomenon through the next generation science standards with confidence and ensures your students master 21st century science skills. The nature of science concepts are built right into your everyday instruction as well. Let's talk a little bit about the nature of science. Teaching the nature of science helps students develop accurate views of what science is and the types of questions science can answer. Performance expectation lessons are a great opportunity to have students take on the many ways of knowing in a meaningful context. The nature of science concepts includes knowing that scientific knowledge is based on evidence. And we know that that scientific knowledge can change over time. As scientists and engineers gather evidence, scientific facts can change. Creativity in the classroom plays a very important role in science instruction. And finally, students' background knowledge will influence the way that they view data. Many students will come to science class with preconceived ideas about what science is and science content. The next generation science standards are designed to incorporate 3 dimensions of learning: the cross-cutting concepts, the disciplinary core ideas, and the science and engineering practices. The cross-cutting concepts are inherent concepts that we find across all areas of science. You won't teach these as separate content, and you don't need to memorize these. They will be addressed in your teacher's guide as we look at our standards pages and even at our lesson pages. The disciplinary core ideas are the facts or the knowing of science. There are specific DCI or disciplinary core idea lessons that deliver the science knowledge. Here are the 8 science and engineering practices. They are a reflection of the process of science. Exploring science will address the performance expectations for each grade level. If we take a look at our table of contents, we can see that there are activities that address the science and engineering practices. These lessons are set apart in the table of contents with colored boxes. The Think Like a Scientist, Think Like an Engineer, Investigate, and STEM lessons are all designed to teach the science and engineering practices. The 3 dimensions of learning come together in a performance expectation lesson. As we look at this 3rd grade performance expectation and tease it apart, we can see all of the 3 dimensions of learning. Make a claim is the same as building an argument from evidence. The merit of a solution to a problem comes from the science and engineering practices number 1 and 6. Cause and effect is our cross-cutting concept, and our disciplinary core idea deals with life science content. Here is an example of a 4th grade performance expectation found in the standards pages in the front matter of your Exploring Science Teacher's Edition. The performance expectation is stated at the top in the long rectangular box, and below that you will see the 3 dimensions of learning, the science and engineering practices, the disciplinary core ideas, and the cross-cutting concepts that go into that performance expectation. You will also see reference to the nature of science connections. These phenomenon are the starting point for each of the lessons and are exemplified in the page photograph. High-impact photography and illustrations help engage students in the phenomenon. Real-world phenomena promote questions or problems that scientists and engineers study on a daily basis. Students build knowledge about phenomena and then put the knowledge to work in the Think Like a Scientist, Think Like an Engineer, STEM, and investigative activities. Let's look at the beginning unit, Let's Do Science. This is a great way to start your science year. You will get a personal welcome to exploring science from one of our National Geographic explorers, and then learn all about the importance of science notebooks. After that, students will learn what science is, how scientists do their work, and they even get a chance to practice science hands-on. A science safety lesson is provided at the back of the book. Even though it is found at the back, it should be taught at the beginning of the year and refreshers given throughout the year as students practice science. The Welcome to Exploring Science feature introduces students to an explorer and what they do. The opening 2-page spread, along with the career inspiration video, really gets students excited, engaged, and curious. The Teacher's Edition will walk you through the introduction with Before You Begin, teaching tips, differentiation, and questions for discussion. Our Explorer also serves as a digital guide, introducing students to their unit through their video. Let's take a minute to view a short excerpt of an Explorer introduction.
My name is David Senge, and I'm from the MIT Media Lab, where I did my PhD designing prosthetic devices. And my research there was at the intersection of medical imaging, design, and manufacturing, where we made comfortable prosthetic sockets for amputees who more specifically were below knee amputees, people with below knee amputations. I think ever since I was young, I wanted to study engineering. I wanted to do a STEM-related field, whether it was engineering or medicine. And I found bioengineering, which was at the intersection of both engineering and health-related design, partly because I wanted to work on products that change people's lives. I knew with healthcare, the quality of life that people had was dependent on what solutions were available to them. And I also wanted to make stuff. I always liked tinkering and breaking stuff. And so a combination of both making and solving healthcare issues led me to bioengineering, and I've enjoyed it ever since.
What a great way for students to begin their science journey. All of our elementary science programs use a science notebook because that's what real scientists and engineers do. Just like we take notes in a class as adult learners, we want students recording full thoughts and critically thinking about their content, not memorizing words to fill in a blank. Fill in the blank questions predetermine student thinkers. We're really passionate about building thinkers, not memorizers. This is a quote from one of our authors, Malcolm Butler, where students can document their scientific experiences in ways they think are important to them. The consistency in recording information in the science notebooks adds more rigor for students as they consider how the recorded information accents their thoughts. Notebooks allow students to express their complete thoughts, which will allow teachers to be able to quickly determine the level of understanding of the content presented in class. Scientists and engineers always begin their work by thinking about what they will do and gathering what they will need. One common tool that you will see scientists use is some form of a journal or notebook to record their observations, diagram their designs, clarify their thoughts, and justify their explanations, just like you see our scientists doing here. We want students to get ready as well. So you will see in each unit, in each grade level, how the Explorer guides students in setting up their notebook and what goes into the notebook. We advocate a type of interactive notebook so that students are emulating what scientists and engineers do in the field. Research tells us that using a science notebook will improve the understanding of both science content and the processes of science. We also know that using a science notebook improves reading comprehension. It also allows students an opportunity to practice science by recording observational data and developing inquiry skills. And finally, every scientist and engineer in the field uses a notebook, so we want to model that with our young scientists and engineers in the classroom. Let's talk about some of the things that your students will record in their science notebooks. First of all, students will have notes. These can be textual or even drawings or graphics. They can have a pocket or a baggie for collected objects. Vocabulary can be recorded, both academic vocabulary and the process vocabulary. Students will also have their investigative observations, materials, and procedures. They can have reflective and analytical entries. They also should jot down any additional questions they have, and they can have their final scientific reports. Setting up the notebook is also an important and fun part of the science classroom for students. Students will learn about notebooking as part of their science lesson. Again, it is an important tool used by every scientist and engineer in their work process. Students will mimic this and develop valuable skills along the way. Students can use any type of a notebook. They could use a spiral, a composition book, or a 3-ring binder. K through 2 students might simply use some folded copy paper and a construction paper cover. You could also put lined paper in if you desire. You'll find many opportunities for students to use their science notebook. In the student books, you will recognize this icon as a time for students to integrate their science notebook into their instruction. To support their science learning, you will find that you will have access to Blackline Masters from the Science Notebook Companion. These can include science and engineering practices, data tables for activities, and student rubrics. These are some of the things that you can think about as you get ready to implement your science notebook into your science classroom. If we want students to be successful using their science notebook, we can model what that looks like. You can carry your own science notebook with you during science class, and you can say things out loud like, "That seems really important. Where should I write that information down?" Or things like, "What science tool can you use to help you remember that important word?" If we ask these questions out loud, this will help students to learn to start asking those questions to themselves. Let's look at just a few examples of what science notebook entries might look like. Here's an example from K to 2 grades. This is a great example, and there's a lot of information here. We have the data recorded in the thermometer. We have the dates, the word, a description, and even a sentence describing that in a beautiful picture. There's a lot of great information too. Even for young students, science notebooking can be a fun, creative activity, yet achievable. Here we see a template with a sentence starter. You can see where they've collected data and recorded those observations at the tops of the columns, their drawings, and the date that they took those observations. Here's a great language arts tie-in. ELA time and writing practice time is a great time to come back and have students enter information into their science notebooks. Again, even very young children can be successful at notebook entries. You can see here where students are doing writing practice on the bottom, and they have their data collection in a T-chart at the top. Again, another great language arts integration in practicing their table of contents. Keep in mind, it's not about the quality of the art, but that the page represents a conceptual understanding of the content that was taught in the science class. This is a great example of a math integration with a scale drawing done here on the graph paper. Also note this is a very intricate drawing. You may have to allow students to take their notebooks home to finish something as detailed as this. Here's another great example of a scale drawing. Now that we've got our notebook ready to go, let's look at the rest of the opening unit. The opening What is Science feature helps to define science as a way of knowing about the natural world. It describes how students use observations, evidence, and inferences to form science explanations. It incorporates the nature of science, helping students to recognize that scientific explanations can change based upon new evidence. The Teacher's Edition uses the 5E instructional model to guide you through this in every lesson. We'll talk more about the Teacher's Edition in a little bit. How do scientists work demonstrates how scientists use investigations to test hypotheses. It describes the process of science, the importance of models, how scientists recognize patterns, and how they use technology. The Who Are Scientists feature discusses the collaborative nature of scientists and how science affects our everyday lives. It shows that creativity and innovation are so important in science and that men and women from all cultural backgrounds can be scientists. All it takes is curiosity. Next, students will get the opportunity to practice the science process. This not only gives them an introduction to science process skills, but gets them hands-on, making them curious and promotes questions. Then you won't be able to stop them from being scientists. Do you recall that I mentioned how our explorers welcome students and introduce them to the practice of science? Well, the same explorer stays with the students throughout the year, guiding the students through each unit with an overview and posing several questions that will begin the exploration. This type of authentic integration is our way of showing the importance of human connection. Again, the Teacher's Edition provides full instruction in the 5E format. You have a Before You Begin section, teaching tips, differentiation, guidance on integrating the video feature, and other teaching connections. Now we're ready to start with our unit contents. This is an example of the strand opener for 4th grade physical science. Your Teacher's Edition will provide comprehensive guidance to help you plan instruction and support students as they engage in 3D learning. This is a typical 2-page spread lesson. As you look at the lesson, you'll notice that the photograph will jump right out at you. This is very purposeful. The photo represents the science phenomenon. It promotes curiosity and questioning. Also notice the additional photographic support and the text captions. The standard and the type of lesson is found on the bottom left of every student book page. The same information is found directly under the title in the Teacher's Edition. You'll notice bolded vocabulary, and finally, you'll see the wrap it up or the check for understanding questions. There is a red icon associated with these questions, and hopefully now you'll recognize that as the My Science Notebook icon, prompting students to record the answers to these questions in their science notebook. Exploring Science has 2 main types of next generation science standards lessons: the disciplinary core idea lessons and the performance expectation lessons. The disciplinary core idea, or DCI lessons, help to build background and also deliver the factual science content. Students will need the content from these DCI lessons in order to be successful in the second type of lesson, or the performance expectation lessons. These are those types of lessons that include the science and engineering practices, or the doing of science. These will also be the focus of the state assessments for states that use the next generation science standards. If you turn to the first lesson of any strand, you can turn to earth science, life science, or physical science, and that first lesson of that strand will be a DCI, or disciplinary core idea lesson. Again, you can see that type of lesson listed in the lower left-hand corner of the student book pages. Those lessons will scaffold into the performance expectation lessons. These are the doing lessons. Again, the DCI lessons will scaffold information into these performance expectation lessons. These performance expectation lessons are those same lessons we looked at earlier when discussing the science and engineering practices. The Think Like a Scientist or Think Like an Engineer lessons, the STEM lessons, and some of the Investigate lessons. This is a great time to go ahead and pause the on-demand training and take an opportunity to just explore some of the things that we've talked about. See if you can identify areas where students will be engaged, where they're addressing the next generation science standards dimensions or performance expectations. Look for some of the STEM content, and what hands-on opportunities do you see? Also, do you see any lessons that vary from the ones that you just saw? As you explored, you might have noticed some lessons called Stories in Science. These lessons are embedded within Exploring Science to give your students a chance to connect with people doing extraordinary things. There are many individuals who have contributed to our society by using science to improve their own lives and the lives of those around them. Some are historical figures, and some are present-day heroes. Many of them have overcome great challenges and adversity to do what they've done. This puts the reality in science and gives students the motivation to explore science because they can see themselves doing extraordinary things like these individuals. I'd like to talk just a little bit more about the investigate activities. I'd like to point out that the investigate activities can be either DCI, disciplinary core idea lessons, or performance expectation lessons. The investigate activities will be DCI lessons when we felt like students needed a little bit more of a hands-on experience to better conceptually understand factual scientific content. You'll also see Science in a Snap activities. These are short hands-on demos or student-centered activities, again, offered up to help students build a deeper conceptual understanding of the content they're learning in their science classroom. Based upon teacher feedback, we've greatly increased our STEM emphasis with special sections called STEM, engineering projects. These are integrated within the lesson sequences to bring real-world applications to the science being learned. Engineering standards are the focus of our Think Like an Engineer lessons and the STEM lessons. Here's an example of a Think Like an Engineer case study. In this lesson, we'll actually introduce you to our explorer, Thomas Culhane. We learn that he is a sustainable urban planner helping developing nations find energy sources, more specifically non-CO2 emitting energy sources. We follow that up with the second part that now puts your students into action, designing and building a solar oven. Here's a kindergarten example of the Science Careers feature. These features inspire students to consider current, topical, real-world problems. They give the message to students that science is exciting, engaging, and an overall benefit to helping others in our society. Inspiring about careers in science can allow your students to see that they can be scientists and explorers. Here's a fourth grade example of science careers. Again, we use National Geographic Explorers to provide students awareness of STEM fields and occupations, and also motivate them by revealing aspects of science that they may have never thought of before. Explorers provide exciting, current, real-world examples of an integration of disciplines without the traditional barriers between science, technology, engineering, and mathematics, focusing on innovation, addressing questions, and designing solutions to complex problems. The new citizen science features prompt students to take action by gathering data for real scientific studies. In the example you see here, students are helping to gather data for scientists who study birds. Here, your young student explorers act like a scientist by making observations, collecting data, and reporting their findings to a larger group. At the end of the strand, the explorer will check back in with the student as a reflection on what they've learned. This includes a checklist students can use to assess their progress and a My Science Notebook activity. You'll also always have both student and teacher rubrics to assess their progress. Let's Let's take a deeper look at the interleaved Teacher's Edition. I know by looking at this page, it's hard to tell that we're actually looking at the Teacher's Edition, but that's one of the first things you'll notice. You'll see the full color 2-page spread lessons that the students are looking at during their science instruction. Directly following the student book pages, you'll see the full instructional pages for that lesson. Notice that the lessons are laid out in the 5E instructional model. You'll also notice how we introduce the phenomenon, and you'll see additional support boxes like the academic vocabulary box or the differentiation boxes. Here's a summary of the 5E instructional model. Engage, explore, explain, elaborate, and evaluate. Each lesson in Exploring Science will be delivered in this 5E instructional method. Notice as you read the definitions of the 5 E's, they infer that students are doing the heavy lifting during the learning process, and the teacher simply becomes a facilitator of that learning. Notice the phrases like get students involved, students need to communicate. The 5E instructional model focuses on students working collaboratively with the content, not just reading and filling out a worksheet. Our program uses a pattern for teaching the phenomenon. Students are introduced to the phenomenon in a variety of ways. Instructions are provided to elevate student thinking, and then there are opportunities to revisit the phenomenon. Here's an example of where we see instruction for teaching one of the 3 dimensions. This instruction focuses on the cross-cutting concept of energy and matter. You may also find small mini lessons within the bigger lessons. Here, students are going to interact with one of our virtual labs called Build It, found on our new digital platform. Let's take a look. Here in the virtual lab, students can begin with a simple exploration. Instructions that pop out from the left-hand side will help them determine how to build a house, a bridge, a playground, or a robot. After exploring, they can enter into a guided activity. Again, instructions will pop out from the left-hand side, and they can follow those instructions to complete their build. Information can be displayed whenever needed, in addition to help. Finally, after they've completed their activity, they can take a picture of the screen and save it and submit it to you as a completed assignment. Additional support boxes include the differentiation. We know how important it is for you to be able to reach every student in your classroom. Differentiation strategies provide support for a wide range of learners, including students who require extra support and those students who are gifted and talented. There are also literacy and math connections that provide strategies for integrating the Common Core language arts and math standards into your instruction. There's even differentiation for English language learners that provide research-based strategies to address the needs of English learners at different proficiency levels. The Teacher's Guide provides detailed preparation before those hands-on experience in the Before You Begin box. Let's talk a little bit about assessment options. Here you see the Wrap It Up. This serves as a checkpoint for each lesson, and students will integrate their science notebook. This will serve as a great formative assessment and meets the Evaluate E, which is the last of the 5 E's. Within your teacher resources, you'll find a rubric for the Think Like a Scientist and Think Like an Engineer activities. Here's an example of a 4-point rubric that assesses the practices. Students also have their own rubric so they can self-evaluate. The assessment handbook has all the tools that you'll need. With the disciplinary core ideas, you'll review questions, use similar images, and vary in the degree of complexity. Here you see a few examples. Notice the performance task here on the right. For additional assessment options, you have Exam View, a test generator that gives you a variety of types of questions within a question bank. You can build tests from the question bank or create your own questions. The assessments can be done in multiple versions, and you can translate the tests into Spanish. The new digital platform, MindTap, has an integrated gradebook. This allows you to track and analyze student performance with ease. You can view class grades for each activity, and then click on a grade for more details, such as distribution of answers by item, or the scores and answers for an individual student. As you get to the back of the book, you'll find the Tables and Graphs resource. This will help students to prepare for organizing data collection. You might think about bringing in your math instructor to help with this activity. And of course, there will be a full glossary at the back of the student editions. All of your print resources, in addition to the Blackline Masters, animations, the virtual labs, and additional interactives, can be found on the MindTap digital platform. Thank you for joining me for the on-demand training of Exploring Science 2019.